President Ronald Reagan was taken through a massive reinforced steel door into the very heart of Cheyenne Mountain, where the headquarters of the North American Aerospace Defense Command monitored the skies of America. The bunkered organization was the first and last line of defense against an intercontinental ballistic missile attack. Encouraged by the complex surveillance consoles, giant computers, interactive maps, and dozens of operators, Reagan asked what the U.S. defensive options were in case of a missile attack. The answer was chilling to hear, even for the president. There was nothing. The only course of action, if deterrence failed, was retaliation. 40 years later, the U.S. ability to take enemy ICBMs from the sky remains practically the same, with even the formidable $40 billion ground-based mid-course defense system only showcasing an average 55% success rate in intercepting Cold War-era missiles. Even so, the ICBMs Russia is testing today far surpass the technology on which the GMD system was tested. Unveiled in 2018, the Avangard hypersonic glide vehicle is Russia's fearful new intercontinental nuclear-capable missile, a weapon so fast it can reach 20 times the speed of sound and avert incoming interceptors in real time. Whether the superweapon is as powerful as Vladimir Putin claims, or if it is merely a Russian bluff, remains to be seen. In the meantime, as Reagan did decades ago, the American people are left wondering how to defend their nation against such an earth-shattering menace. Stopping an incoming supersonic intercontinental ballistic missile is a daunting, desperate task. Monitoring agencies have only seconds to identify the launch, trace its trajectory, and inform the President of the United States, who must determine whether to launch an interception in a split-second decision. The U.S. Defense Network must have anti-missile equipment relatively close to the site where the ICBM has been launched, and then hope that the countless variables that can turn the interception into a failure roll in their favor. As one military official put it, it's like, quote, striking a bullet with another bullet in space. The complexity of the whole affair is part of why the U.S. and its allies have been forced to rely on nuclear deterrence as their primary defense against a possible nuclear attack. Despite short and medium-range anti-missile solutions, like Israel's Iron Dome being highly reliable, things become exponentially more challenging with large missiles with speeds of up to 3,682.89 miles per hour. As such, intercepting hypersonic ICBMs that can reach speeds of 15,345 miles per hour is impossible with current technology, and the nature of such missiles has led the world into another dreadful arms race that, if we are to believe Russia's claims, the United States is losing. In March of 2018, Vladimir Putin surprised the world by revealing that Russia had two operational hypersonic weapons: the Kinzhal, a fast, air-launched missile capable of striking targets up to 1,200 miles away, and something worse, the Avangard, designed to be attached to a new Sarmat intercontinental ballistic missile before maneuvering towards its targets at speeds of Mach 20. Russian media have also asserted that nuclear warheads for both weapons are already being produced, and that the Avangard missile has already been successfully tested 3,000 miles across Siberia. Numerous American experts have cast doubt on Putin's bold claims, assuring that there's no evidence that the systems can perform as advertised. Nevertheless, the Pentagon is taking the threat seriously. Even if the Avangard is not an immediate menace, it soon could be. In his ominous address to the Russian High Command and the media, President Vladimir Putin described the Avangard as an intercontinental ballistic missile capable of traveling at a speed of Mach 20 and hitting its targets like a falling meteor. The dictator added, quote, "The weapon is capable of performing sharp maneuvers on its way to targets, making it absolutely invulnerable for any missile defense system. The Avangard is a hypersonic glide vehicle launched to orbit using an intercontinental ballistic missile. The projectile travels through space towards its destination before gliding down towards its target at hypersonic speeds." During its documented test over Siberia, the Avangard flew inside a UR-100NU ICBM, and according to Russian media reporting the event the following day, the Avangard re-entered Earth at a speed of Mach 27, or a staggering 20,716 miles per hour. If this estimation is accurate, there's no weapon on Earth capable of intercepting an object moving at such speeds. The weapon is allegedly designed using advanced and classified composite materials capable of sustaining temperatures of over 2,000 degrees Celsius and the overwhelming friction caused by the hypersonic speeds during re-entry. The Avangard hypersonic glide missile can reportedly change course and altitude at very high speeds, making them virtually invincible, according to Putin, who also compares the military breakthrough of this development to the creation of the first artificial satellite on Earth, the iconic Sputnik. The Russian reports coincide with Pentagon intelligence, which also describes a high-speed missile being tested by Russia in late 2018. However, American officials have not confirmed the specific details claimed by Putin. Even so, the fact that Russia could now be armed with hypersonic, nuclear-capable intercontinental missiles is a top concern for the U.S. Defense Department, which has lately multiplied its efforts to produce a new generation of American hypersonic ICBMs to deter the threat posed by Putin's Russia. Many critics of the Russian regime have expressed doubt about the Avangard program, citing Russia's long track record of menacing bluffs regarding weapons of mass destruction. One engineer working on American ICBMs even told the New York Times that, quote, "Their test record is more like ours. It's had a small number of flight test successes." Nevertheless, even if the chances are low, Russia having operational, maneuverable hypersonic ICBMs would mean they have already surpassed the U.S. military in that respect. The dreadful possibility has forced many U.S. congresspeople to urge the Pentagon to accelerate its development of new hypersonic missiles capable of standing head-to-head with the Russian Avangard. Numerous politicians have interpreted Russia's claim as a clear sign that Washington has fallen behind Moscow in the hypersonic missile race. Therefore, they are pressuring the Department of Defense to give the utmost urgent priority to the continuous development of American maneuverable hypersonic ICBMs in the hopes that the technology can serve as a deterrent to a Russian attack. Representative Mike Turner, a ranking member of the House Intelligence Committee, said, quote, "We're behind our adversaries in hypersonics," as he urged the House of Representatives to take immediate action on the national security issue. Piercing through the Russian propaganda veil is impossible. As such, knowing for sure if they are ahead in the hypersonic missile race will not happen for a while. Still, America must take the threats very seriously and prepare to respond as if every single claim is valid. Even if most evidence points to a bluff, underestimating Russia could be a catastrophic mistake. The US is now conducting its own series of hypersonic ICBM tests, but Russia might have up to a 4-year advantage with the Avangard, and American missiles don't seem to have the ability to swiftly evade interceptors like the Avangard claims to have. With the conflict in Ukraine escalating rapidly, the entire world is hoping the United States' recent developments are enough to deter the Russians from further escalating and even deciding to use the Avangard in the Eastern European conflict. While most 20th century battles were fought on the battlefields, a new kind of warfare is expected to take over the world in a few decades. After years of belligerence and endless one-upping, the United States is finally fighting for control of the Taiwan Strait. And in a surprising maneuver, the U.S. Space Force has deployed a scheme almost 100 years in the making. Developed as part of Project Thor during the Cold War, the mystery weapon involves 9-ton tungsten rods that are dropped from orbit. As the telephone pole-sized rods fall from the sky, the objects are supposed to reach 10 times the speed of sound, hitting the Earth with as much power as a nuclear weapon. While challenging the 1967 Space Treaty without technically breaking the agreement, the United States might just be on the verge of weaponizing outer space with its kinetic rods from God. Days of the Cold War, outer space became a crucial subject of study to use it for warfare applications. However, one of the most significant problems of using space as a postmodern battlefield is that nuclear, biological, and chemical weapons in orbit have been banned since the Outer Space Treaty of 1967. Still, there may be a loophole that the United States has tried to take advantage of for decades. Instead of relying on chemicals and engineering for its devastating impact, a new kind of weapon could depend solely on its mere kinetic force. In fact, Earthside kinetic strikes have already been used as far back as World War I, when masses of heavy metallic objects were dropped by aircraft on top of enemy positions, with the effect being proportional to machine gun fire. During the Vietnam and Korean Wars, there was some use of lazy dog bombs, a kinetic projectile shaped like a conventional bomb that could reach 500 miles per hour during its fall, penetrating up to 9 inches of concrete. However, all rules change in orbit. In a kinetic orbital strike, a solid object would be dropped from orbit towards a target, and the sheer power of the kinetic impact would be similar to the explosive yield of a ground-penetrating nuclear weapon. Enter Project Thor, a long-rumored program that dwells on these matters and is developed by the United States Air Force. While the New York Times referred to the concept as tungsten thunderbolts, a more common nickname is simply rods from God. The weapon system would supposedly involve a satellite carrying a magazine with heavy objects, most likely telephone pole-sized kinetic projectile rods made of tungsten, each weighing around 9 tons, with fins attached to keep them straight. These sorts of destruction weapons would orbit indefinitely in space until needed, and they would always be ready to be whisked into any corner of the world within minutes. Powered by gravity alone, the rod would then be directed toward a target while gaining tremendous velocity and speed. Going faster than 5 miles per second in orbit, the weapon would eventually reach an impact speed of an eye-opening Mach 10. Initially developed by former Boeing operations researcher Jerry Parnell, the weapon's concept has inspired more than one science fiction story, especially as the originator later became a writer. Still, many believe the rods from God could actually be ready for deployment soon, or that they're already lurking in space. For decades, the American military has spoken in hints and whispers about its plans to develop kinetic weapons in space. And while no Pentagon official has yet acknowledged how far along the research is, or even confirmed that any sort of effort is underway, the concept persists to this day. In 2002, a Rand Corporation study named Space Weapons Earth Wars dedicated several pages to the different applications of kinetic weapons technology. At a time when the Pentagon was on an all-time high alert after the September 11th attacks, an Air Force report gave what analysts call the most detailed picture since the end of the Cold War of the United States' efforts to turn outer space into a battlefield. Released in November of 2003, the United States Air Force Transformation Flight Plan report makes American space supremacy a top-ranking priority for the 21st century. The document runs through dozens of research programs designed to ensure that America can never be challenged in orbit, and they range from anti-satellite lasers to weapons that would provide the capability to strike ground targets anywhere in the world from space. In addition, the publication references non-nuclear hypervelocity rod bundles in its outline of future space-based weapons and claims that the United States sought to use the kinetic weapon as a bunker-busting platform. Upon hitting the Earth's surface, these tungsten rods could penetrate hundreds of feet into the ground, releasing built-up kinetic energy and creating an explosion equivalent to 11.5 tons of TNT with zero fallout. However, according to rumors that surfaced after the Air Force report was published, if the so-called rods from God ever materialized, it wouldn't be for at least 15 years. Several detractors spoke out about the development of such weapons, claiming that it would also prompt many countries to respond with something similar, potentially sparking a worldwide arms race in orbit. Soon, the rumored project went dark once again. According to several experts, the biggest fault of the rumored project has always been money. In 2020, the cost to carry a single pound into space was around $10,000. With the rods weighing almost 10 tons each, the project became cost-prohibitive. But despite the hefty price tag, many kinetic weapons concepts have continuously re-emerged since the end of the Cold War. And some of the technology behind the rods from God has somewhat been used by the American Armed Forces. In 2012, naval research claimed the successful use of a 25-pound hypervelocity projectile with 32 megajoules of energy that penetrated 7 steel plates. And as recently as 2020, a 100-pound modified kinetic weapon fitted with detachable blades for extra impact was dropped from an aircraft on top of a terrorist vehicle. Ultimately, it is believed the rods from God could become a reality in the next few decades if engineers and project planners can work out the exorbitant price tag. In 2018, the Chinese government released CCTV footage showing 3 wide-area vehicle scaled-down models involved in an aircraft air release test. Conducted in the Jiuquan Satellite Launch Center of China, the 3 models then fell into a free flight state after being lifted to high altitude by a balloon. During the freefall, the objects exceeded the speed of sound, but their parachutes finally opened to land and recover. According to netizens, this unique and strange test indicated that the ultimate rods from God weapons were copied by China and will soon be launched. Meanwhile, in a meeting with the United States National Space Council, former President Donald J. Trump declared that it was not enough to have American presence in space, but that complete dominance was a necessity. That day, Trump directed the Department of Defense and the Pentagon to establish the 6th branch of the United States Armed Forces, the Space Force. Inaugurated the following year, the ever-growing organization is also fully supported by President Joe Biden's administration. Notably, the Space Force's 2022 budget request amounted to $17.4 billion, a significant increase from the previous year. If accepted, the budget would grow the service by up to 8,400 spacefarer satellites from the Army and Navy to the new service. In addition, the Space Force would finance more than $800 million in new classified programs. Perhaps enough to fund the Rods from God program once and for all. The United States government established the Strategic Defense Initiative Organization during the late stages of the Cold War. Created to render intercontinental atomic warfare obsolete amidst the rising nuclear tensions, the organization sought to create a protective shield that negated an enemy's first strike advantage. While the organization was active, several revolutionary concepts were studied, including brilliant Pebbles. Conceived as part of a pre-existing concept, the brilliant Pebbles were small, maneuverable, rocket-powered, laser-equipped vehicle systems that were able to detect, track, and intercept enemy ballistic missiles when placed in orbit. The idea was to send thousands of Pebbles to circle the planet, ready to make an appearance at a moment's notice. When necessary, the tiny missile interceptors would destroy their prey by smashing into them. Most experts believed the project was too good to be true, but it soon became the main focus of the entire organization, responsible for developing strategic defenses. Not even budget cuts would prevent the brilliant Pebbles from beginning trials in 1990 and proving everyone wrong. In the early 1980s, Allied strategic analysts began speculating that the Soviet Union would soon achieve nuclear supremacy. If true, Russia would become capable of crippling the United States' strategic retaliatory forces and still have enough nuclear weapons left to destroy entire cities. As a result, the Joint Chiefs of Staff working for President Ronald Reagan recommended placing more emphasis on their missile defense strategies. A vocal critic of the mutually assured destruction doctrine, Reagan soon announced the launch of an expanded research and development program on live television on March 23, 1983. During his speech, the president called upon American scientists and engineers to create a system that would render nuclear weapons obsolete. Moreover, the Strategic Defense Initiative Organization, or SDIO, was officially established a year later, after lengthy technical studies. First led by Lieutenant General James A. Abrahamson of the Air Force, the organization, nicknamed Star Wars, was set up to protect the United States from attack by ballistic strategic nuclear weapons. One of the initial projects was Project Excalibur, proposed by Lowell Wood and Edward Teller of the Lawrence Livermore National Laboratory. The weapon used an X-ray laser driven by a nuclear warhead that could simultaneously attack dozens of intercontinental ballistic missiles. However, it was abandoned in 1986 after several failed tests. After that experience, the duo decided to further the smart rocket concept. Proposed by Daniel O. Graham, the weapon used large battle stations with powerful sensors that carried dozens of small rock-like missiles. With a minimum of 423 stations needed to keep enough missiles above the Soviet Union at all times, the project had many critics, including the Air Force and Teller himself, who dismissed the concept as outlandish and vulnerable to attacks. According to the theoretical physicist, his take on the project was not only clever, but brilliant. Designed in 1987 by Lowell Wood and signed off by Teller, the brilliant Pebbles ballistic missile defense system needed a constellation of pebbles and nothing more. The system consisted of thousands of small missiles, similar to conventional heat-seeking ones, that would be placed in orbits so that hundreds of them could be above the Soviet Union at all times. In the case of a Russian ICBM fleet launch, the brilliant Pebbles would detect the rocket motors due to infrared seekers and then collide directly with them. According to a New York Times article, quote, "Speeding through space a few hundred miles above Earth, a pebble would need only a nudge from its engines to send it hurtling towards a rising missile." Because the Pebbles would strike the ICBM before it could release its warheads, each rock could destroy several warheads with a single shot. Compact and intelligent, the Pebbles would only be 3 feet long and weigh around 100 pounds, with their brainpower housed in a silicon chip as a supercomputer. According to Wood, the state-of-the-art technology used in the Pebbles would make them so smart that they would be able to perform their mission without external supervision, a significant novelty in the mid-1980s. During peacetime, each Pebble would be housed in a protective life jacket, charged by solar-powered panels to keep it ready whenever needed. The brilliant Pebbles proposal's main idea was to sow space with between 10,000 to 100,000 Pebbles. With a price tag of around $100,000 each, it would be fairly inexpensive to orbit the entire constellation. In 1987, the American Physical Society published a report stating that none of the weapons being studied by the SDIO were remotely ready for use, and would mostly need at least another decade of research. By then, the brilliant Pebbles concept had been refocused and now used small orbiting missiles similar to conventional air-to-air missiles. This process was expected to be much less expensive to develop and deploy. At the same time, the brilliant Pebbles became the main design proposal of the entire project in 1990. As the crowning achievement of the Strategic Defense Initiative, it was soon ordered into production. According to then Vice President Dan Quayle, the brilliant Pebbles system could revolutionize American strategic defense. However, numerous experts criticized the level of attention given to such a relatively new idea, and many believed it to be doomed, like many older Star Wars concepts. Even so, Army Major William O'Connell, an SDIO spokesman, stated that 12 brilliant Pebbles flight tests, 8 suborbital and 4 orbital, had been scheduled from 1990 to 1993. Assuming that the system successfully completed the entire cycle tests, full-scale development could begin right after, with production starting as early as 1996. The first brilliant Pebbles test was carried out on August 25, 1990. During the trial, the explosive bolts that were supposed to separate the rocket fired much earlier than planned, causing the fairing to flip over to one side and pull the Pebble partially out of the airframe. The second test happened on April 17, 1991. During that exercise, the system did not pick up on the target, and all subsequent movements were delayed and much less accurate. The third and final tests took place on October 22, 1992. Using a miniaturized prototype closer to what a production model would look like, the device began to break down only 17 seconds after liftoff. The model had to be destroyed by a safety officer as several pieces kept falling off the booster. While brilliant Pebbles was modified, the changes increased the price exponentially, and the cost for 4,600 Pebbles had ballooned to an alarming $55 billion. By then, the Soviet Union had already collapsed, and the mighty Red Enemy was no more. Soon after taking office in January of 1993, President Bill Clinton's new Secretary of Defense, Les Aspin, initiated the downgrading of the Pebbles system, beginning with a budget cut from $100 to $75 million. After that, the U.S. Congress continually fought over the project's promise and future. However, when the SDIO was officially shut down by Clinton that same year, the brilliant Pebbles project was officially over. Also, SDIO was replaced by the Ballistic Missile Defense Organization, which put more emphasis on regional rather than national missile defense. Nevertheless, space-based interceptor development was resumed almost 30 years later. With President Donald Trump signing of the National Defense Authorization Act, the Space Development Agency now manages the program. As part of the new National Defense Space Architecture, early development contracts were awarded to L3 Harris and SpaceX. At the time of its revival, CIA Director Mike Pompeo called for additional funding to finally develop a full-fledged strategic defense for our times. It is called SDI-2. A mighty new weapon concept was born in the early years of the new millennium. It was the Multiple Kill Vehicle, a high-precision machine that could target several threats at a time with a single launch. By releasing a flock of smaller weapons, the Multiple Kill Vehicle, or MKV, would be capable of accurately addressing a threat and intercepting both real missiles and decoys before any harm reaches the nation's borders. The Pentagon's project would struggle to generate much traction during its early years, but it said that the promising device might just be the weapon America was waiting for. As the world's superpowers continually try to step up their games when it comes to the aerospace industry, risky and almost impossible designs usually come to the surface. One such design was the first system capable of destroying multiple ballistic missile threats and decoys with a single launch. The Multiple Kill Vehicle was a transformational program that added to the capabilities of a warfighter and was designed as a force multiplier for all land and sea-based weapons of the Integrated Mid-Course Missile Defense System. It would also boost U.S. missile defense capabilities, making them more effective. These next-generation systems provide interceptors with the ability to defeat multiple complex threats with a single launch, and could potentially thwart an attack with only one missile that would in turn release a cluster of objects, including a warhead and several look-alike decoys. The vehicle's purpose was to keep people safe. Ideally, any incoming missile should be destroyed before it reaches its target, and the MKV was the part of an interceptor able to strike an enemy warhead and limit its ability to cause damage by using the force of impact alone. The hit-to-kill force of impact technology, pioneered by Lockheed Martin, is the current standard of all U.S. missile defense systems. In contrast, the MKV program's aim was to create smaller and lightweight vehicles without sacrificing lethality. Fully integrated, the payload's design would fit on both existing and future interceptor bombers. In case discrimination proved challenging, one or more vehicles could be queued to intercept credible targets within a threat cluster. Moreover, MKV was potentially able to solve most of the toughest countermeasure challenges that could surface. After the launch of an enemy missile, a fully loaded interceptor vehicle would track down its target by running data from the ballistic missile defense system uplinked to a seeker installed in the carrier vehicle fitted with a set of sensors. Once in outer space, the seeker would spot all objects posing a threat, namely the missile itself and any form of countermeasures launched to disrupt national defenses. The carrier would then deploy smaller vehicles in large numbers and guide them to destroy the targets. While engaging an enemy, the divert and attitude control component is designed to handle the carrier vehicle. Together with all the 8 to 20 smaller attack vehicles, control would maneuver them towards the threat's path. By having the enemy in sight, the carrier vehicle would be able to disperse the attack vehicles and guide them accurately to a direct collision that would destroy them in mid-space. This strategy, referred to as many-on-many fighting, completely eliminates the need for extensive pre-launch intelligence. What's more, the ballistic missile defense system's discrimination capability is leveraged, and a robust and affordable solution is ensured against emerging threats. Led by Lockheed Martin Space Systems Company, the MKV-L development team has worked on the project for the Missile Defense Agency, or MDA, as far back as 2004. Critical design reviews and hover tests took place during the following years, while flight tests began in 2007. 2 operational prototype seekers were built with a state-of-the-art infrared large-format focal plane array. Most specifications remain classified. However, it was known to feature a low-risk, high-performance, liquid-fueled divert and attitude control system. An individual MKV-L was about the size of a loaf of bread. Notably, the small warheads were kinetic energy-based and further equipped with their own navigation thrusters. These vehicles weighed about 10 pounds. The modular design approach was supposed to allow for several configurations in the number of kill vehicles deployed, as to address a broad range of scenarios. In addition, the program sought to demonstrate the feasibility of this machine by using conceptual designs, analyses, simulations, flight testing, and key hardware trials. Both existing and emerging miniaturization technology was evaluated to be integrated into a functional system in the future. On December 2, 2008, a test was conducted at the National Hover Test Facilities in Edwards Air Force Base in California. The team included Lockheed Martin, the prime contractor for the Multiple Kill Vehicle L payload system, as well as Pratt & Whitney Rocketdyne, a United Technologies Corporation, and Octan Technologies, Inc. According to several reports, the objectives were achieved, including having the MKVL hover under its own power. Furthermore, its ability to recognize and track targets in a flight environment was proven, and its propulsion system demonstrated maneuverability while chasing a target. Also, the vehicle transmitted video and flight telemetry to the ground. In accordance with the MDA's layered approach to ballistic missile warfare, the vehicle provided numerous opportunities to destroy an adversarial missile, increasing the possibilities for a hit on the warhead using a single target cloud. Hence, the system was supposed to enhance the MDA's ground-based mid-course defense element. Nevertheless, the project was terminated under then Secretary of Defense Robert Gates in April of 2009 due to Pentagon budget adjustments, but revitalized 6 years later in a similar program, the Multiple Object Kill Vehicle developed by Lockheed Martin, Raytheon, and Boeing. The Multiple Object Kill Vehicle offers several benefits to the ballistic missile defense system. By increasing firepower, it allows multiple vehicles on a single target, all the while reducing dependence on a priori target information. In addition, it works within the standards of existing and planned systems, enhances mission flexibility, and has the ability to intercept multiple independent targets. As an optional payload for mid-course defense systems, the concept mitigates the need to isolate a single lethal object. In 2017, U.S. missile defense experts spent $112.7 million refining the capabilities and reducing development risks of the future ballistic missile defense multi-warhead killer. The threat dynamics in the contemporary world are dire and include North Korea's missile capabilities, nuclear weapons and space vehicles, Iran's unyielding nuclear ambitions, and China's intercontinental ballistic missiles. Consequently, the Pentagon and its partners in the industry are constantly pressured to engineer the ultimate defense system, a faster, adaptive, and highly impactful next-generation interceptor, and to do it by the end of the decade. The Missile Defense Agency plans to hire contractors for a long-term strategy to create a new weapon by 2028. Building upon the performance of existing ground-based interceptors, the next generation should feature innovative command and control technologies, computer processing, flight speed, precision targeting, and sensing discrimination. A senior Pentagon official familiar with such technology has told the National Interest, quote, "It has to be able to take out the latest generation of ballistic missiles that might proliferate from Iran or North Korea, find its way through a maze of countermeasures, and use an effective filtration system for the optics that can see and pick out the warhead, and hit it every time." He then added, quote, "We're asking these teams to come up with the best NGI they can. We went with letting the teams know specific requirements and giving them enough leeway to do the best they can do. Many of the technical specifics were left up to the offerers. The future remains uncertain, and the specifics are unavailable for security reasons, but several competitors are now offering NGI solutions, including a Northrop Grumman-Raytheon joint effort to merge Northrop's rocket booster, data networking, and computer expertise with Raytheon's kill vehicle and sensor discrimination improvements. The defense industry is only getting started.